Thank you so much for coming. This is Ops 200. If that's where you wanted to be, you're in the right place. This talk is called What's New in Modern CI/CD. There are a lot of slides here and a lot of text, and I encourage you to take pictures if that's easier for you. You don't have to read everything. Don't stress out if you didn't get through everything before I continue on. All right, so let's start this show. All right, so I'm Villasenor. I'm an engineer at Google. I work on DevOps and CI/CD products, and I'm really excited to be with you today. And my colleague Nate Avery is here. He's a product manager at Google in this space, and he'll be covering the latest from us later in the presentation, and I'll let him introduce himself then. All right, so here's an overview of this talk. We're going to go through the basics of CI/CD, why this new stuff is better, and an overview of the renewed focus on software supply chain security, which everyone's talking about, including the White House. We're also going to talk about the latest from Google in this space, because it wouldn't be Cloud Next if we didn't include that part. So, all right, so just to level set everybody, what is CI/CD? I like to talk about it like this. It's the combined practices of continuous integration and then either continuous delivery or continuous deployment. We'll talk about what those mean in a second, but that's what the acronym stands for. And for those programmers in the audience, this pseudocode might make a little more sense to you. So let's break that down, right? Continuous integration is the first step of any pipeline, right? It's the practice of frequently pushing all changes to a main branch in source control and then running automated builds, unit tests, and integration tests off of those builds. The next stage is continuous delivery. This is where that built and tested code from the previous step is continually delivered to a production-like environment, also called staging. You can increase the confidence that your deploy is actually good when you use a system like that. And then finally, there's continuous deployment. And this includes all of the previous steps, but adds one crucial additional step, which is an automatic deploy to production if all of that testing looks good. I should note that we only see this usually with very mature DevOps organizations, because you need to have high confidence that a green light from your pipeline means you're actually good to go to prod, and oftentimes that's not the case. So in practice, what does this actually look like, right? It all starts with the local development environment, that first line of code. And then that developer pushes that code to source control, like Git, right? And then we hit the CI or the continuous integration, and that's where the building and the testing happens. And then you have either continuous delivery or continuous deployment, depending on what you're feeling comfortable with. And it doesn't stop there. There's often smoke testing after prod deploy, and then some security controls. Wait a second. Security controls. That's the last step? Hold on. I don't think that's right. I think we actually need to shift left, right? Yes, it's a bit of a buzzword, and that's super annoying. But they actually have a point. If you take care of all of your security reviews before you get too far down that delivery pipeline, you're going to have a much, much better time. Because imagine if you depend entirely on a third-party library that is later deemed completely unacceptable. I mean, you'd have to start all over, right? Like, what a waste of time. So modernization, right? Like, sounding pretty good right now, right? So I want to tell you a personal story about why this is so important. So one time I took down prod because I did a deployment incorrectly, and this wasn't at Google, but it was still scary. And this wasn't just one service, this was everything, globally, for 5 minutes. Scariest 5 minutes of my life. If you're an SRE, you know this pain. So you might be wondering how that was even possible, right? It all boils down to the fact that the deploy was a manual process, and that required editing some text files. And if the deployment before didn't go correctly and it wasn't cleaned up properly, then the next one would run into trouble if you didn't check the configs. If you've seen something like this, you're very familiar. We had a checklist of how to deploy, but that wasn't sufficient to fix a problem that was outside the bounds of a checklist, right? So this is why we do this. Automation for your pipeline, repeatable builds, infrastructure as code, right? It all contributes to a more stable software delivery lifecycle. And stability means happier engineers, better security, and of course, happy auditors, which is a nice thing. It's also clear from data that has been collected as part of the DevOps research and assessment surveys that continuous delivery performance actually predicts software delivery performance, which also predicts organizational performance. And this is in like real ways that you can measure, like market share and engineer burnout. And if you've ever submitted code to a pipeline that takes forever, only to find out, I don't know, 7 hours later, that your code didn't even work, right? You understand this pain. Knowing when something is broken sooner is always better for engineering happiness and efficiency. The other thing I'd like to mention is that high CI performance shines even brighter when it's combined with better security. And teams that follow safe practices and have a well-developed CI were found to be above average in terms of organizational performance. If you enjoyed this mix of organizational psychology and tech, I highly encourage you to check out dora.dev. It provides a wealth of information that helps teams get on the right track. And there's a little QR code here if anyone wants to take a picture of that. These slides will also be available later, so no stress. All right, so let's take a step back real quick and look at some other challenges in traditional CI/CD. Elasticity, portability, and maintenance. Let's take a step back, right? There's some challenges with traditional CI/CD, right? Elasticity is usually the primary concern. Non-elastic infrastructure is bad for performance and cost efficiency, right? I want to zoom in on this graph because I love it. During peak, if you have a static infrastructure set up, like a bunch of build nodes that are always the same, you're not getting the performance you want when everyone's trying to check their stuff in and check it. And then you're also paying for idle machines off peak, right? It just doesn't really make sense. And then there's the portability problem, right? If you depend on plugins that are specific to your tool, and then you need to move platforms, you're locked in, right? And then there's maintenance, patches, repairs. That's all on you. So how does modern CI/CD address these things? Well, it starts with portability, right? With containers, you run your stuff on any cloud, any CI/CD system, right? And if you depend on your CI/CD system's plugins, that makes migration pretty difficult, so we try to avoid that if we can, and containers are a great way to just bring your house with you, right? And then 2, elasticity, right? Only pay for what you use and get what you need at peak with a managed service. And then in addition to the elasticity benefits of a managed service, you also get ephemeral environments that avoid the headache of patching, maintenance, and making sure that your environments are secured from one another. All right. So I promised I'd talk about this because this is a super hot topic. Supply chain security vulnerabilities. These are nasty. There's some challenges here, right? Because when we're talking about software supply chain security, we have to think about the entire spectrum. Everything from that first line of code, making sure that developer locally is authenticated, to day 2 when that workload is in production, right? And when we look across the entire spectrum, the number of attack vectors that can be used to compromise our supply chain is crazy. And traditionally, the far right side of the spectrum is where we spend most of our time and focus. And we do a pretty good job of it now, bin auth, things like that, right? However, this is where we're starting to see a problem. Local dev dependency injection issues. So there are 4 key challenges here. First, nobody writes everything from scratch. Most people pull from common open source frameworks and libraries, and the majority of those projects don't require signed commits, 2-person code reviews, right? That doesn't mean open source is bad. I love open source. It just means you have to be careful. And I'm be the first to tell you that increased CI/CD automation is a great thing, but that also means an increased number of deployments, which means increased risk, right? Security has not been top of mind for many CI/CD systems for years. Many of them run with root. It's just easier. Oh, I don't know what the problem is, just give it root. And then with the increased adoption of containers, you have this proliferation of outdated base images, because sometimes your base image is so far up that chain that you don't even remember how to update it anymore, right? So the sheer number of possible attack vectors here and the dynamic nature of CI/CD makes this hard to protect, because the security of the entire supply chain is only as good as its weakest link. The good news is that this space is getting a ton of attention. Regulatory bodies are getting involved, and there's a number of emerging standards as well. All right, so let's go over a few concepts on how we're addressing this. So the three fundamental ones are provenance, where and how it was created, transparency, what's inside that artifact, and then finally, impact. Are we actually affected? Do we need to care about this, right? So let's go through each of these and see how we can actually use these to improve our supply chain and not just talk about buzzwords. All right, so talking about provenance first. So there's this acronym we came up with called SALSA, which is really funny because we have another one called guac, right? So we just like have this theme going with like food. Anyway, it stands for Supply Chain for Software Artifacts, and it's a framework under the OpenSSF. Its creation was led by Google, and in many ways it externalizes an internal framework that we've had for years for Borg called BAB, Binary Authorization for Borg. Think of it as a checklist of standards and controls to prevent tampering, improve integrity, and secure packages and infrastructure. It's all about getting from where you are today to that next level of software supply chain security and not jumping to something crazy. The SALSA guidelines are a really great way to do this because they're divided into several levels for incremental adoption. Level 0 is basically where everyone starts, no provenance at all. Level 1 can be achieved by just documenting your automated build process with provenance so that it's clear how your artifacts were built. Level 2 requires your CI/CD system to generate and sign that provenance itself. And this is most easily done with a hosted build platform, but you can technically do it anywhere. And then level 3 builds on everything else by adding strong isolation between builds. They really shouldn't be influencing each other. And the secrets that are used to sign that provenance should not be available to the build itself. Think about the problems that could cause. So why does this matter, right? Like, this isn't just a compliance thing that we have to think about. We want to use this data downstream to actually do things, right? If the builders are creating provenance docs, then we can make decisions downstream on whether something should run, right? Binary authorization, if you've heard of that, we can use this data to make decisions at that point. And of course, you know, I should mention, we do support the highest level of SALSA as a V1 in our products as well, so check those out. All right, so transparency is next. So SALSA was all about the provenance of our builds. SBOM, or Software Bill of Materials, is about the content of those artifacts. So you can think of it as like an ingredient list on a can of soda, right? In addition to listing what's inside that artifact, SBOM also includes information about the provider of that artifact and how different artifacts relate to one another. And yes, we support it in our products as well. All right, so what is the actual impact of these software supply chain vulnerabilities, right? Like, we've covered provenance with SALSA and artifact transparency with SBOM, right? But if you're doing anything with even a small amount of complexity and scale, you're gonna have vulnerabilities, right? And that's often super overwhelming because you're in this fire drill trying to patch millions of endpoints before your SLA for patching is over, right? And that's where VEX comes in. VEX stands for Vulnerability Exploitability Exchange, and it's an additional standard that brings context to this whole situation. Basically, if there are vulnerabilities in the software, depending on the call graph, they might not even be reachable or exploitable, so what's the point in patching them, right? And it does this with what's called impact statements. A VEX impact statement provides a way for us to indicate that a specific vulnerability is not impacting the specific application because of X. It gives a reason. You don't just have to believe it, right? A good example of this is a vulnerability that is specific to a runtime, like Wasm, for example. If your app is distributed as a container image on GKE, it's probably not exploitable. So our approach to supply chain security on Google Cloud is twofold. One, we want to integrate these time-tested practices based on open standards and put them in our products, bake them in, make it easy to use. And we're focused on the open source community as well. And we provide leadership around things like standards, SLSA, technology, OSV scanner, fuzzing, shared open source. And we integrate software supply chain security at every step in our pipelines, right? All of these products work together and secure your software supply chain because it's only as strong as that weakest link. We look at this space in 4 parts. The first is the local developer experience. I think a lot of people forget about that, but it's actually super important, right? Secure access to source control is a difficult problem to solve, right? Verifying identity, scanning for vulnerabilities and licensing information at the time that that information is introduced into your system. 2, the supply of artifacts needs to be scanned and verified to be clean. And you can do this yourself with our artifact analysis offering. Or there's assured open source as well, which does a lot of that work for you. And then CI/CD is where the SLSA, SBOM, VEX stuff comes into play. You want to make sure that you're generating signed artifacts with proper metadata. And then finally, at runtime, we want to make sure that deploy systems are incorporating admission controls that use that metadata we talked about earlier to actually make decisions on whether something should run. And then all of these areas are underpinned by a unified set of policy controls. All right, so let's dive a little bit deeper into some of these that are my favorite. So managed local dev, right? This is something that I think the industry as a whole needs to think a little bit more about. Our solution to secure local dev is this thing called cloud workstations, which provides cloud-based dev environments for existing GCP customers. This is an extension of the Cloud Shell that you know and love, but we support running those workstations on your own VMs in your VPC instead of using our resources. And this benefits 2 types of people. I think this is really great for a central DevOps team that can automate management and security policies for their team's dev environments, like with workstation templates. And then also developers have an on-demand, pre-configured workstation, right? The days of, oh, it works on my machine are gone because everyone has the same machine, right? So continuing with that local dev story, there's this thing, Cloud Code Source Protect, which brings dependency, vulnerability, and license awareness directly into the IDE without blocking productivity. And this all seamlessly works with cloud workstations because it's just a VM, right? With these 2 things together, your central DevOps teams and developers can securely manage developer environments and create secure applications. This is currently in private preview, but if you talk to your account rep, I'm sure they can set you up with something. All right, so let's learn about the latest from Google, and I have Nate here to walk you through that. Thanks so much. Thank you.
Okay, so I know some of you flew in last night, maybe you flew in this morning, and it's been a long day. And I am the only thing standing between all of you and happy hour. Great. So I'm going to let you in on a little secret. We have release notes with a lot of this stuff in it. So if you happen to feel parched, you can go to the docs. But if you want to hear about why some of these features are like really cool and why we think that they're compelling and why we believe that they're going to enhance your experience, then please stick around. I'll try to make it go quick, though. All right, everything starts off with the basic CI/CD pipeline. It reads from left to right. You have your IDE, in this case that's going to be Cloud Workstation, paired with Cloud Code. We have a source code repository. We have build, handled by Cloud Build. We have artifact analysis and artifact registry for your package handling needs, as well as your security vulnerability scanning. And then Cloud Deploy is a dedicated tool built for deployment. And then we have our runtimes. So that's GKE, Cloud Run, all those really cool modern ones where we can do things like the binary authorization. So let's talk about Cloud Build. As you can see, there's a lot here. This isn't quite everything that it does, but these were a lot of features that were released over the last year or so. And before we talk about some of the specifics, let's just handle some of the basics about Cloud Build. Cloud Build is our CI solution, and it's meant for automation, and it is unopinionated. And by that, we mean you can set up your tasks any way you want to, fine by us. Every one of the build steps is an ephemeral container, and those containers share a common workspace, which allows you to actually pass information across from one to the other. So earlier, Mia told you about Salsa, and she told you that Cloud Build handles Salsa. So we're going to move on. I told you, I'm going to try to make this work. So binary authorization. Binary authorization is pretty cool. And I know a lot of folks, in our talking with them, they don't always turn it on. And some of that is because there's like a fear, maybe it works, maybe it doesn't. But let's try to remove that fear by talking about it a little bit more and helping you understand what's happening. It works, you can think of it as a series of trust-based policies, right? You say, I want this to be the thing that blocks a container from running. And that thing can be described in a couple of different ways. Usually, it's going to be defined using all of the stuff we told you about before, like Salsa, SBOMs, VEX, all of that. So you could say, I want to stop anything that has a security rating of high or greater. You could also say, I only want to run things that were built in Cloud Build, right? So you have the opportunity to make that work however you want. And if you take a look at the binary authorization configuration page, you can also run it in a dry run mode, where you can just kind of take a look at it, see what would have happened had you had it running, and those results will be in the logs. Okay. So again, the basics of it is that if something shouldn't be running, then it'll stop it. And that's really the whole idea of this. You want to make sure that the thing that you've developed is secure over here. As it's built, it maintains its integrity, and when it's running, it is still that same thing. Okay, so once your apps are running, and this is actually on your runtime, GKE or Cloud Run, you're going to get one of these really cool security insights panels. It's similar to what you saw before. However, this is with content that's actively running. It will analyze your Kubernetes configurations against the pod spec security standards. Where it will then highlight any deviations that it finds. Pretty much, what's wrong with my environment? Am I good to go? Okay, let's go back to some of these other features. I work in product, and so I can tell you that once a product is launched, things happen. We learn a lot about how people really use these products in the real world. And in this case, a trend just started really taking over, and I know all of you know it, is infrastructure as code. And what we found out was that people really, really wanted to use Terraform to create infrastructure as code for everything, including how their pipelines are built. So that was one of the features we added. It was a very well-received feature, I'll say. Every now and then we get to do some things that customers really like, and this was one of them. We'll move on. So, Cloud Built's free tier. This is something that's out there. You're all encouraged to try it. You can get a lot. As you can see, you get 2,500 free built minutes per month. And one of the other things that we've done, I think I can go back real quick. The E2 standard 2 default machine type is now the default. It's a lot. It's kind of redundant. But what it means is that you're going to get a faster built machine, right? And so that will actually help you in your processes, get things going in your CI/CD pipeline, hopefully end things a little bit faster from the perspective of your builds. Next, we'll talk artifact registry and analysis, which are there, okay, up top. A little bit of background for those of you who may not be too familiar with them. We used to have this product called Container Registry. And Container Registry was really nice, but it did what it said. It stored containers. And as time went on, we realized that people needed to store more than containers. They needed to store application packages along with them. Maybe they needed to store OS packages along with those. And so now we have Artifact Registry, which is a universal package management system. It tries to cover everything, and in that, it also ties into our security controls, so that's CMAC, VPCSC, auditing, and vulnerability scanning. The vulnerability scanning, by the way, comes from artifact analysis, and that same artifact analysis provides scanning at a couple of other layers in the system. Here's a list of a few of the features in AR. And judging by the number of folks who signed up for some of the pre-GA features, we knew that some of these were going to land fairly well. For instance, remote and virtual repositories. Cleanup policies was another one. And the other thing that happened was, while we were releasing new formats like Yum, App, Go, some of the other ones, some folks said, well, what if we have something that's not one of those? So now there's also going to be a generic type available. That should cover, hopefully, a lot more of the folks and really make it that universal tool that it's intended to be. Okay, so we'll talk about virtual and remote repositories. This feature, it strengthens, I'm tired, a little parched, your dependency governance and simplifies access to ports. All that, really what it says is it's going to give you like a universal URL to your repos. Remote repos, on the other hand, point to an upstream repo. So we'll go to this guy. Let's say I have a simple Python app that I made up. What I'll do is I'll configure some of those packages for the ones that I've created to be stored in my standard repo. I'll create a remote repo that pulls anything that can't be found from PyPy. And then I'm going to use a virtual repo underneath that I point everything towards. So in the end, by using that one point, I've lowered a lot of the cognitive overhead of a developer. They don't have to remember all the different URLs, all the links to figure out where to get packages. But then something else really cool happens, and that's, you can kind of see it over here. There's a priority tab, priority column, you can set the priority such that it tells which one should be pulled first. So in a lot of cases, what you're going to want is to look at your local repo before it goes out to a third-party repo. Once more, this is a quick reminder that we have scanning, which can be run on push. We also have scanning that can be run on demand for a variety of package types. Cleanup policies. It's pretty obvious. I mean, we put it right there on Front Street. It's for cleaning up files in your registry. It's really neat, though, because it does more than just define policies for deletion. You can also define which files to keep. You can apply up to 10 of these policies per repo, and they're defined with JSON. Pretty basic stuff. This right here is what a delete policy looks like. Not a whole lot there. If you know JSON, yep, that's what you expect. This is what a cleanup policy looks like. It actually looks pretty darn similar. What you'll notice, though, is that in a keep policy, the action type is of type keep. Okay, cloud deploy. There's one thing I want to mention before I really get into cloud deploy, and that's the fact that this whole system here, they're made up of individual applications, and any of these applications can be replaced with a third-party tool. Now, we're not going to fight you if you want to use all Google tools, but if you have something that you prefer to use for your builds, if you have something that you prefer to use for your artifact scanning and analysis and storage, or you just think you have a better deployment tool, that's fine. We're trying to make it so that we'll meet you where you are. Feel free. You can swap out parts as you go. You don't have to do it all at once in a big bang. Cloud deploy. It's an interesting product, cloud deploy. Some folks don't quite get it when they come to it. It can be a little bit challenging because it is focused specifically on deployment. That's what it does. It doesn't do builds, it just does deployments. However, it does it really, really well, right? It does it in an opinionated way. Now, opinionated here means that it has certain best practices and policies and all that stuff kind of built into it. And this is a list of all the features of Cloud Deploy that were launched in the last year. Team's been super busy, just cranking away, and there's a lot here. Okay, yeah, verifications there, SDS insights. Almost everything that's here is designed for making sure that you have a very fluid capability to deploy onto our modern runtimes like GKE as well as Cloud Run. And the other thing that's really neat about this is that the team goes extra far and that they want to make sure that those features that work for one of the runtimes will work for all of the runtimes where possible. So we'll talk about Canary. I think most of you know what a canary is, but real quick, a canary deployment is a progressive rollout of an application that splits traffic. Essentially, you have one that's already running, and then you want to have a new version, so there's some percentage of traffic split out to a new one. With Canary and Cloud Deploy, it's up to you to set what those thresholds are. You can start with 5%, 10%, 25%, whatever you want. It's up to you. You figure out whatever it takes to make you feel comfortable knowing that the deployment is safe. I want to now talk about parallel deploy. This one's really cool. It affects different people different ways, but what it does is it allows you to deploy to multiple clusters at the same time. So let's say you've got a cluster on the East Coast and you have a cluster on the West Coast. You can drop the same deployment onto both of them. We also have deploy parameters. So this works in conjunction with parallel. So if we go back to that example of east and west, maybe there's a little more traffic running on the East Coast, so I will set a number of nodes at 8, and there's a little bit less traffic on the West, so I will set that at 6, and that's perfectly possible. That's just one of the examples, but when you really start looking at things, most deployments get sticky at points, and parameters can be a big help. Deploy hooks. This is another one of those features that was added to address real-world deployment needs. Real quick, they are user-defined actions that can run either before or after, or both before and after your deployment. So, I remember doing deployments back in the day when I needed to maybe update a database schema before I could run my deployment, so that would be a pre-deploy hook. Maybe I had a custom script that I needed to run after the deployment, that would be a post-deploy hook. What's really neat is that it takes a lot of those things, those tasks, those chores that we used to do maybe outside of the deployment tool, it brings them back into it, so that you actually have a really nice automated system that automates all the stuff you need and not just parts of it. Oh, this one here. In-console onboarding. This one is one of my favorite features because I will admit something real quick. When I first came to the team, I tried to launch Cloud Deploy, and I walked through it, and I realized I could not create a pipeline using the GUI. It was weird. I thought it was weird. But there was thoughts behind it. There's a lot of thought put into all of the applications. But I kind of walked away from it thinking, I'll get back to it later. And so I happen to know from talking to folks that I wasn't the only one. So if previously you did what I did and said, I'll check it out later, you now can do that. It works really smooth. It's in the GUI. Run through it once, get your idea for what works. Maybe do a quick POC, and then if you really want to do it after that, you can jump into the YAML files. And one last note. We believe in this tool so much so that the price has been adjusted. And this is really something that goes along with an overall feature that we want, which is accessibility. We want folks to feel like they can come to these tools and give them a run and improve their experience. And we realize that price is a big part of that. So now, I want to make sure I say this right so I don't get in trouble with legal. You can use pipelines with a single deployment target at no cost. Single target, no cost. But then anything other than that, if you need a more fully fleshed out pipeline, those have been dramatically reduced in terms of price. So really at this point, it's a really cool product to jump into. Between the price change and the GUI setup, we're really doing whatever we can to make it easier for folks to at least take a look at it. So to wrap it up, there are a few things that happen in a modern pipeline. And we all have some technical debt that's already in there. What we're hoping to do is to provide you with tools that at least reduce how much technical debt you have going forward. That's really kind of the goal. So if any of you are out there and you have blockers to that, or you found some things that you don't quite like about the tools, that's fine. Most of us are available in social media circles. We'll be downstairs in the booth. I think I've got both days, Wednesday and Thursday. Just come by, tell us what you like, tell us what you don't like, because the team takes that feedback very seriously. So, thank you.